What's up, math scholars? Thanks for joining me to watch this video today. On Friday, we kind of started at the end of the study guide and worked our way backwards. So today we'll start at the beginning of the study guide and work our way forwards until we kind of meet. So just let this Mrs. Benson know when we get to the place where we had finished Friday, and she'll stop the video and then give out some just additional practice problems for you to work on the rest of the period, okay? So I'm at air testing today, Monday, and then I will be back tomorrow, Tuesday, to answer any questions you may have, and then we'll play math speed dating, and your test is on Wednesday, all right? So let's try number 1 here. We're converting from degrees to radians. If you didn't notice yet, there is a formula sheet on the back of the study guide. So you can just look at where I have converting from degrees to radians, and you can find out we need to multiply by pi over 180. So 275 times pi over 180. Just a reminder, you can pause the video at any time and catch up if you find that I'm going too fast. 275 pi over 180. We are going to look for a common factor to divide out of the 275 and the 180. Let's go with the 5. So 275 divided by 5 is 55, and 180 divided by 5 is 36, and I can't forget to put my pi there on the numerator. So our final answer, 55 pi over 36. All right, number 2. You can use your unit circle here below. We're going to answer with a single letter for all these questions. There is a unit circle in the back provided to you if you need to use that as reference. All right, negative 270. So negative 270 would start here at 0 degrees and spin in a clockwise direction. That would be a negative direction. Negative 90, negative 180, negative 270. So we would land up here at the same exact position as 90. You also could have done a negative 270 plus 360 to find out that negative 270 and 90 are at the same place. So we're up there at 90. We want the cosine value. So just a reminder, cosine is x and sine is y, if they should ask, as far as your coordinate. So we would want the first half of the coordinate. That would be r. All right, 5 pi over 3, if you look on your unit circle, you can discover it's at the same location as 300 degrees. 300 degrees is down there in quadrant 4. Since they're asking for a sine, we want the y value, or the second half of the coordinate. And that would be n. All right, 135. You would want to spin yourself until you get to quadrant 2, since 90 is up here at the top at RS. 135 would be located at TU. And since it's sine, we want the second half of the coordinate, U. All right, 660 is a rather large number, so let's subtract 360 from it. 660 minus 360 is 300. 300 is located down there in quadrant 4. And the cosine value would be the x value, so m. Negative 150, you can either spin negatively 150 degrees, or you can do my plus 360 trick to find out it's at the same exact location as 210. 210 is located in quadrant 3 down here, and since it's a sine value, we want the y value. So we'll with W. So our answers are R, N, U, M, W. Right, we want the area of a triangle, and they're providing 3 side lengths. Now we did learn in this chapter 2 brand new area of triangle formulas. For this one, we would want to use that Heron's formula. So it should be on the back on the formula page. It sure is. The thing about Heron's formula, and I'll just write it up here for you guys to see, is you have to figure out what S is. And S is a semi-perimeter, which is a half perimeter. So you actually want to start by finding that value. So let's start by finding our half perimeter. So I'd do 1/2, and then I'm going to find the perimeter, 6 plus 12 plus 14. So 6 plus 12 is 18 plus 14 is 32. 32 divided by 2 is 16. So my half perimeter is a 16. It's a very important number to have to be able to use the formula. I'm going to put this down in the box. As far as A, B, and C, you can just call your 6, your A, your 12, your B, and your 14 your C, and then you're ready to use the formula. So it's going to be S, which is 16, times S minus A, times S minus B, times S minus C. And I kind of told you be cautious and maybe don't plug all that in the calculator, but do little pieces and parts in your brain, really. There's no reason you can't do this stuff in your head. 16 minus 6 is 10. 16 minus 12 is 4. And 16 minus 14 is 2. And at that point, you can probably go ahead and type it in. I ended up getting 35.78, and that would be units squared. I'll type it in one more time just to double check myself. But you can type it in with me. Square root of 16 times 10 times 4 times 2. 35.777. So I just rounded that. This is islands. Find the exact value of cosine 240. You could definitely just turn to your unit circle and look at that. 240 is down there in quadrant 3, and we want the x value for cosine. So negative 1/2. Number 5. We want all possible theta that are between 0 and 180. So you're going to go on your unit circle, and you're going to look up here in quadrant 1 and quadrant 2, because that's where the angles between 0 and 180 live. And you're going to look for all y values of 1/2. All y values of 1/2. So I'll give you a second to look and like do a seek and find game there. Look for all y values of 1/2. So hopefully you found that 30 and 150 have sine values of 1/2. And I just want to point out they are supplements. Remember how we learned the supplements trick? That supplements have the same exact sine value? That's why those are your two answers. Okay. Number 6, a steep section of a road has an 8% grade, meaning it rises 8 feet for every horizontal 100 feet. Let's find the angle theta that the road makes with horizontal. I definitely need to sketch this out to kind of think about what's going on. So this is my road. It's not too steep. The picture is probably even steeper than it actually is. But an 8% grade means it's going to rise 8 feet vertically for every 100 feet it travels horizontally. Okay. So hopefully that makes sense to you how I have my picture. We want to find theta, which is the angle that the road makes with horizontal. All right, so we've talked a lot about all of our strategies we know to solve triangles. If it's a right triangle, we can use sine, cosine, or tangent, SOHCAHTOA method. If it's a non-right triangle, we've got the law of sines and the law of cosines to choose from. So think in your head what you want to select to solve this triangle. Did you go with tangent? All right, that is correct. So tangent of theta equals 8 over 100. And the way we're going to solve for theta is we need that tangent to kind of cancel out and go away. So we're going to use a tangent inverse on both sides. Tangent inverse. So as far as the calculator is concerned, second tangent, 8 over 100. It's probably a good time to make sure your calculator is still in the right mode. Sometimes they get switched without you realizing it. So I got 4.57 degrees. Number 7. All right, on this one, you really have to think about your inequality symbols and what they actually mean. If cosine of theta is greater than 0 and sine of theta is less than 0, what quadrant is your theta in? Let's think about our unit circle here. If our cosine value is greater than 0, that's a fancy way of saying the x value is greater than 0, which actually just means that x is positive. The sine value is the y value, and if the y value is less than 0, that means the y value is negative. So we just need you thinking about what quadrant would have positive x values and negative y values. It would be down here. All these numbers down here, I would have to travel to the right to get there and down, which would make it a positive x value and a negative y value. So we're in quadrant 4. And you do want to use a Roman numeral for your quadrants. You'll be a true math scholar. Math scholars use their Roman numerals. All right, time to convert from radians into degrees. So let's start with our 22 pi over 3, and this time multiply by 180 over pi. What's nice about converting in this direction is your pi's always cancel. You're going to cross cancel each other. You scribble them out. Head to the calculator. 22 divided by 3 times 180. That's a big answer. 1,320. And that's in degrees now. Put your little degree symbol. Number 9, we're going to find the cosecant of 60. So what I do want you to do is just kind of think about cosecant and remember a little tidbit about cosecant. Cosecant is the reciprocal of sine. So probably your best and easiest bet is just take the sine of 60 and then whatever answer you get, flip it upside down. Sine of 60, if you look at your unit circle real quick, is going to be radical 3 over 2. So the cosecant would be 2 over radical 3. Now we did talk about how true mathematicians would definitely rationalize that denominator, so I'm going to do it real quick because it would be a breeze to do. Multiply the top and bottom by radical 3, and that would give you the final answer of 2 radical 3 over 3. Well, I will accept either answer in the pink or the black. I know a lot of you are headed to pre-calc next year, so you would aim to be a scholar and give me that answer in the black. Number 10, find the area of a sector with radius 4 and theta of 60 degrees. We had a very similar question like this on the quiz that you guys took, and if people miss this problem, it's because they forgot to do one key step, and it needs to be your first step, honestly. What you need to do is convert your angle of 60 degrees into radians, because the formula we use has to be in radians. I mean, I have it up on the board. Asterisk, theta must be in radians. So converting 60 to radians will be a piece of cake because it's on your unit circle. 60 in radians is pi over 3, and that's what we're going to be using as theta in our sector area formula. So sector area formula, it is on the board, 1/2 r squared, which is radius squared, times theta. So 1/2 times 4 squared times pi over 3. I'm going to go ahead and type that in with you just to check my answer that I have on my paper. 1/2 times 4 squared times pi over 3. 8.3775. So let's round that off to 8.38. It's an area. So they don't really tell you what our units are, if they're inches or feet or whatever. So just go units squared. Right, I think we'll do one more in the video. We should probably have got to the problem where we would have met up from what we had done on Friday. Okay. So number 11. Let's sketch out the triangle. Anytime they don't have a triangle sketched, I like to see it. So we've got triangle TYL. in which L is 20 degrees, TL is 4, and TY is 3. So give me a second to sketch that out. Make sure you look like me. This would definitely be one of those side angle scenarios. I always like to say, do we have a complete set of partners, class? What would you say? Yes, we do. That 20 and that 3 are definitely a complete set of partners that we know. So law of sines can be utilized. So let's kind of just start ourselves off by setting up that sine of 20 is partners with the 3 and sine of angle y is partners with the 4. The y. Kind of write it like that just so you can tell it's a y and not a 4. Alright, so let's do some cross multiplying together, everyone. Go ahead and take 4 and multiply it by sine 20. Either click enter at this point or close off that parenthesis. Divided by 3. That number you're looking at, that 0.456 number, is equal to sine of y. So we still have one more step we have to perform. Sine inverse on both sides. So in the calculator, I do second sine, second answer key to plop that 0.456 in. 27 degrees. We've talked a lot in this chapter. If you're going to be using the law of sines and you do a sine inverse to finish out the problem, you have to explore the possibility that the supplement of 27 could also work. So let's just explore that. What's the supplement of 27 degrees? 180 minus 27 gives us 153. We have to see if 153 would work or not work in that slot, in the y position. So 153 plus 20 would give me 173, and I would still have enough degrees left for angle T. That would make angle T 7 degrees, so it's okay. So to answer this question, when they say find the measure of y could be 27 degrees, or y could be 153. So we might have an acute triangle, but we might have an obtuse triangle that would have the given measurements. All right, well, thanks for watching the video today, guys. Let's see how long it's been. It's been 17 minutes. You'll still have plenty of time in class to do some extra problems. So print something off and have Mrs. Benson give it out, and it's up to her if you work together, work by yourself, put answers up, okay? She is a math teacher, so feel free to ask her any questions. She's more than qualified to be in charge today. And hopefully you're having a happy Monday. See you tomorrow.